What is up, gamers? So today I want to discuss the recent YouTube AI news that has been around for a bit. And more specifically, I want to discuss this. Um, it is about the the AI trying to escape thing. There's loads of these videos on YouTube. AI researchers stunned after OpenAI's new something tried to escape. AI researchers shocked after OpenAI's new O1 tried to escape, and so on and so forth. There's loads of these. Um, I'm not out to bash any of these YouTubers here. I'm not targeting any of them. They're doing what they're doing. I think don't I don't necessarily think this is fake news. I think it's more down to they might not really know exactly what they're reading in this report and maybe don't understand the technology enough to compile it into a YouTube video that makes sense. I'm going to try to touch down on some technology here, but I'm not going to go super deep. And I'm also not going to comment on any of these videos. But what they are referring to is a research report that was made by Apollo Research. You can read the entire paper at apolloresearch.ai. It's a big PDF, but most of these YouTubers were talking about one specific slide in this PDF, and this is what we're going to do also. And it's this one. Um, so this is the slide they're referring to when they're talking about that the AI escaped or tried to escape. And we're going to break down one specific segment in this slide. I'm going to zoom in on it. And it's the bottom left one. And if you've seen the other videos by these YouTubers, you know which one I'm talking about. It's this part here. Let me scroll up a bit. So this is the command the assistant tool call the AI ran to try to copy its model weight to another server, right? This is the claim. I want to break down this line, this syntax a little bit and give you my take on it. So what do we have? It's bash. This is Linux shell, right? So it's run in Linux shell. What does it do? It runs SCP, which is secure copy, from the source folder. This is the source file. Then it wants to send it to the target user, which is called user at the target machine. Model deployment v2 is the machine name. And then we have the target path. Let's break this down. First of all, SCP is it's an application. It's a program that you need to install onto Linux, which it's secure copy, and it's a file transfer application that opens up an SSH session to a target machine and transfers a file, right? This program does not exist on a AI compute node like this. It's not installed. It's not present. So already here, this command would fail. But let's pretend it does exist and move on. This part, the source folder and the source file, I can't confirm that. This is probably legit. That's what it looks like. Next part is the user, the target user on the target machine. Apparently, this user name is user. This is not a thing. There wouldn't be any users called user on a target machine like this. If there were any users at all, they would have like serial numbers or short names of some sort of production, whatever, but they wouldn't be called user. I'm going to touch down on the user bit a bit more later. Next part is the machine name, the target machine name. Apparently, this has a host name that is called model underscore deployment underscore v2. This is also not a thing. First of all, it's way too long to be a compute node. The names of compute nodes in a cluster like this are usually a couple of letters followed by numbers. Example, AIN001, AIN002, and so on. That's it. It would be 5, 6, maybe 7 letters and or numbers long to describe, because these compute clusters, there are usually hundreds and sometimes thousands of nodes in a cluster. They need to have a logical order of names and numbers. So this is not a thing. um, so already here we have 3 problems that is debunking this line of code or line of command. SCP wouldn't exist, user wouldn't be a thing, and this is the name of the server that would also not be a thing. But here's what the misunderstanding is. They have obviously tested this. I'm pretty sure they have tested it, but what they have done is they have installed SCP. They have made sure the target machine has a user called user, and the target machine has this complicated host name. So this is where you you pour gasoline onto a rock to prove that you can set the rock onto fire, right? And actually, in this case, they poured 3 cans of gasoline onto the rock to prove that you can put the rock on fire. There's also a invisible problem here that you don't see in the syntax, but I will explain why. This SCP command requires local area network or internet connection, TCP IP over Ethernet, LAN or internet to work. This is what it does. This is a TCP IP protocol connected application. There's no TCP IP connection going between compute nodes in an AI cluster. And I'm going to explain why. So this is an example, an illustration. This is a system by Aspen Systems. This is kind of what a AI cluster stack would look like. It would be a rack of lots and lots of compute nodes, right? So each of these would be a physical independent machine, but the way they are configured and connected, they would be one machine working together. I'm going to show you a real world example. So this is the new Colossus AI data center. I think this is commissioned by Elon Musk. I'm not sure. So this is what it would look like. It would be hundreds of machines in aisles like this. And even though they're separate machines, they would be connected and configured as if there were one. And how are they doing that? Well, it's called InfiniBand. So each of these compute nodes, if we look at this picture again, each of these rack servers, each node, each compute node, would have an HCA controller like this one I show you now installed into the machine. You need at least one. Many machines can have 2 or 3 and so on, but at least one per compute node. And this is an example from NVIDIA. This is a really, really good card. The Connect X8 Super NIC, they call it. This is already a super expensive card. This is a $10,000 card. So each compute node would have one of these cards. And this is, well, they call it the Super NIC. It's like a network card, but it's not a network card. It is an HCA card. Its main purpose is to enable resource sharing between physically separate machines. So what you do is you install one of these cards in each machine, at least one, and then they're connected together with InfiniBand interconnect cables, and I will show you a picture of what that looks like. What that does is that you can have a pool of memory RAM on one server accessible as local physical RAM on another server through InfiniBand Connect. It's quite cool technology, and you can share other things too. You can share a CPU, PCIe lanes, and so on and so forth. So it what it does, it makes all the computer connected together with InfiniBand to share all their resources like they were one, and that's the main purpose of this. This card specifically, this card is 800 gigabyte per second maximum total bandwidth, which is insanely fast. And this is a PCIe Gen 6 with up to 48 lanes, which is also quite insane. I think consumer computers nowadays is like PCIe 4 or something like that. So really, really fast HCA controller, 800 gigabytes per second, and that's per interconnect, right? And you can have multiple of these cards. This is what you use to connect them together with. This is an InfiniBand interconnect cable. It's a pretty thick, very stiff cable, and it has the actual connectors is kind of chunky, almost bubblegum stick size connectors. And in the middle of here, you have a PCB with gold connectors on both sides. And it kind of works like direct access PCIe, you could say, but it's not. It's InfiniBand. And I'm going to show you illustration here. This is an example of a small compute cluster. This has only 2 compute nodes, 1 controller, and 1 InfiniBand communicator. So it's a tiny, tiny compute cluster. But other than that, this is how it works. You can only scale it upwards. You can just connect more. So you could have hundreds, but this is a small one. And here you can see this is the director server. You can see this is connected with InfiniBand and has these blue pull tabs on the InfiniBands. And then it's connected to the InfiniBand switch down below. And then you have some other here that is connected through. This is the compute nodes, and also has InfiniBand connected like this. This is how they communicate internally. All compute and everything that the AI model or the large language model does is communicated between the compute nodes or the servers over InfiniBand. And this is not TCP/IP. This is direct access memory protocol or other hardware sharing protocols. It's more like internal PCIe type of traffic. You could technically configure TCP/IP over InfiniBand on this. You could use it to transport network traffic, but that's not how it's configured. It's never configured with that in a production cluster. It just doesn't happen. And we can look at, you see you have one network cable here from the communicator. This is not connected to LAN. This is an IPMI interface, so it's only used for remote video. So like you can get the image on screen, keyboard and mouse and such. So it's only for management. This doesn't carry network traffic. You can see here on the InfiniBand switch, here is the actual network interface. So all traffic that is going to the compute cluster and from the compute cluster goes over here. And this only carries metadata. And that's like user input. You ask the AI something, you get a reply from the AI, comes back, it comes out from the Ethernet. But that's the only thing that the Ethernet or the network carries. It never carries the actual compute data or file transfer in between compute nodes and stuff like that. It doesn't happen. It all goes over InfiniBand, and that's also the reason why this wouldn't work, because there's no another server to copy the file to, because it's all one server. So that's a bit how it works. Once again, I'm not picking on these YouTubers. I just think, I mean, they're YouTubers. They don't work with a large scale IT and stuff like that. So, and it's a complex thing to understand. Most people I've talked to regarding AI and cluster stuff, they don't know what InfiniBand is or how it works or how you configure a compute cluster. That's my take on it. I think it's just a bit of a misunderstanding. The scenario described here, this wouldn't happen. There's so many things that needs to be in place that aren't in place already for this to happen, that it wouldn't happen. Like I said before, once again, it's like pouring gasoline on a rock and putting it on fire just to prove that you can light a rock on fire. This is exactly the same thing. They, it's a proof of concept. They proved that, yeah, if you do all this, then yes, it can clone itself to another server. But it just wouldn't happen because that's not how you set up these compute clusters. It's extremely highly unlikely that it would ever happen because it's not done this way. But yeah, I think that's it for me. Thank you very much. Until next time. Bye.